So you found a failure in your PCB, maybe a short, an open, or a suspicious solder joint. What now? Let's walk through the essential steps to identify, verify, and fix that failure efficiently and reliably. The first step is confirming the failure mode. Is it electrical, mechanical, or thermal? A simple electrical test may show something is wrong, but X-ray inspection gives you the why. Whether it's a cold joint under BGA, a void on a QFN pad, is it a short circuit or a missing solder connection, heading pillow, or a solder void. Non-destructive is very important, non-destructive. Once you spot the defect, classify it. X-ray imaging helps visualize the root cause. So let's start with the short. Short may result from excessive solder or poor solder mask design or even manufacturing. Opens may be caused by misalignment or coplanarity issues. Heading pillow, on the other hand, is usually an oxidation of the pad or the component solder ball on the BGA, for example, which causes an improper reflow. We got to keep in mind, not all boards are worth reworking, right? So you got to ask yourself whether the component you're trying to replace is replaceable. Will the fix affect performance or reliability? What is the cost of rework compared to just scrapping? For high-value assemblies, it may make more sense to do the rework, right? If the damage is not too deep, especially in multi-layer structures, it may be better to just start fresh. If you are reworking, you gotta do it correct. Use proper thermal profiles when reflowing, replace oxidized or damaged components. Inspect the rework zone with X-ray again to validate repair. Tools such as 2.5D, which is a tilted view on the X-ray inspection, or computer tomography, reveal hidden issues like lifted balls or internal delamination after rework. Validation is critical, right? Do not assume that you did the rework and now things are fixed. Verify it, like Reagan said, trust but verify it. Use X-ray to confirm mechanical integrity of your board. Run functional and thermal tests to confirm electrical reliability going forward. Right, so all this thing has to be put together in one concise process. For critical applications such as aerospace, medical, defense, automotive, this step is absolutely essential. Finally, ask why the failure happened in the first place. Many failures trace back to incorrect solder paste volume, poor thermal profiling, oxidized parts, or even improper board handling. Use what you learned to prevent next failure before it happens. That's why X-ray is so critical. You have the feedback loop that helps improve your process. Every failure is a lesson if you know how to read it. And to learn how to read it, you have to use the right tools. And with the right tools and the process, you're not just fixing boards, you're actually building reliability for your company. So if you want to become an X-ray expert, do not forget to download our free ebook. The link is going to be in the description. And do not forget to subscribe for more industry insights. And again, thanks for watching.